UNICEF has initiated a program to promote the professionalization of manual drilling in Africa. This program is designed to increase access to safe water in rural areas and help countries to reach the MDGs. Supporting UNICEF with technical assistance in this effort are Enterprise Works Vita and Practica Foundation. Achieving the MDGs for water supply in sub-Saharan Africa is a daunting task because the magnitude of the problem is ever increasing. In sub-Saharan Africa, the number of people without access to clean water actually increased by 32 million people between 1990 and 2006, despite massive investments in the sector. The burden of collecting water in Africa falls mostly on women and children, who often must travel long distances to fetch water. 80% of the unserved people in Africa live in rural areas, and many live in small villages in remote locations that have proven too costly or too difficult to reach with conventional drilling programs. These villages may not even be considered in the National Plan for Water Supply. Conventional drilling in Africa is very costly due to many factors, including the lack of competition, high cost of machinery, lack of spare parts, and limited maintenance facilities. The lack of adequate infrastructure, including roads and bridges, make it difficult for large rigs to reach remote drilling sites. Large diameter concrete wells for village water supply have also proven to be too costly for small villages. A complementary option, in places where it's appropriate, is manual drilling, but it will require the development and professionalization of the manual drilling sector through investments in training and equipment. Fortunately, the equipment is inexpensive and can be made and repaired in small welding shops located in many towns across Africa. The first step in the professionalization of the manual drilling sector is the mapping of the potential for manual drilling in 20 countries in Africa: Mauritania, Togo, South Sudan, the Democratic Republic of the Congo, Nigeria, Benin, Mali, Chad, Senegal, Guinea, Guinea-Bissau, Cameroon, Sierra Leone, Côte d'Ivoire, Madagascar, Burundi, Liberia, Burkina Faso, Niger, and the Central African Republic. The potential for manual drilling is based on the geology. Favorable geologies include unconsolidated alluvial and soft sedimentary formations. Manual drilling is best suited for areas where the static water table is less than 25 meters deep. Once these two criteria are mapped for a given country, the maps are combined. More detailed in-country mapping will follow that will also consider the number of unserved people living in favorable manual drilling areas in order to assess the potential impact on the MDGs. With support from UNICEF, the World Bank, and USAID, the professionalization of the manual drilling sector has already begun in Niger, Chad, and Senegal.
In the current situation, the United Nations Children's Fund, UNICEF, considers that hand-drilled or low-cost boreholes constitute an important priority to achieve the Millennium Development Goals. Why? Because in Niger, the levels of access to water and sanitation are very low. And in order to increase these rates, it is necessary to go to the communities where the potential exists to use low-cost technologies. These communities often have fewer than 250 people. Low-cost boreholes are a good technique, and at the end of the testing, we are going to approve them and add them to the framework of techniques used to find and supply potable water to the population. Under suitable conditions and using appropriate methods, we think that this method is a method to promote not only in Niger, but also in all countries of the world where the need is felt for a better approach to provide potable water for the people. Within our scope of work in rural water supply, the Water Ministry initiated the installation of low-cost boreholes in 2005. These wells were done on an experimental basis in small villages. For these small villages to be able to benefit from a modern water point, it is necessary to use low-cost boreholes, which are equipped with rope pumps. When this technology was presented to us, we were a bit hesitant before trying it. But now we are really convinced by this technology, and there is a lot of demand from villages who want to have these wells. For this reason, we would ask you to try this technology, whether it be in Niger or elsewhere in Africa or the world.
Although Niger is experimenting with the combination of rope pumps and manually drilled wells for small communities, all types of pumps can be used on manually drilled wells. Once completed, a manually drilled well is the same as a well drilled by a machine. Creating a professional manual drilling sector in a country is a process of capacity building that takes 3 to 5 years. It begins with a detailed mapping to determine the potential impact of manual drilling on unserved rural communities. Often the areas that are suitable for manual drilling are where people are living, because historically they have used traditional methods to get water from these shallow aquifers. Government support is essential for the development of manual drilling. Initially, governments may be concerned about the quality of the final wells, and this is where standards, quality control, and training become important. In Chad, manual drilling has been accepted as part of the official rural water supply strategy. It is important to carefully select businesses to train to become professional manual drillers. They need to be established businesses with a keen interest in the sector and an understanding of the importance of providing a professional level of service. In addition to training well drillers, a parallel training in manual drilling for quality control firms will be essential. A professional manual drilling sector must mirror the established norms from the mechanized drilling sector. This is a capacity building process. The goal is not to simply drill wells, but to establish the capacity to drill low-cost wells in the country. In the next section, we will look in more detail at 4 manual well drilling techniques. Rotosludge is a technique that uses circulating water to remove the cuttings from the hole. The up and down motion of the drill, combined with a partial rotation, cuts into the ground. The cuttings flow up the hollow drilling stem and are removed from the well. Therefore, there is no need to remove the tools to clean out the hole. As the well is drilled deeper, additional pipes are added to the drilling stem. Rotosludge is ideally suited to wells drilled in clay soils to the depths of 30 meters. Hand augering is a technique that is ideally suited to drilling in unconsolidated soils to depths of about 15 meters. It uses different drill bits depending on the soil type. The auger is turned so that the bit cuts into the ground until it is full. Once the bit is full, all the tools are lifted out of the hole and the auger is emptied. As the hole gets deeper, extensions are added to the auger. Once the water table is reached, a specialized auger is used to bale the sand out of the hole using a combination of rotary and up and down motion. Hand augering is often used to start the hole in combination with other techniques. In jetting, a small motorized pump is used to pump water down the hollow drill stem. A rotational and up and down action supplied by the drillers cuts the ground. Jetting is similar to rotosludge in that circulating water is used to bring the cuttings out of the hole. The water jet also provides a cutting action. Jetting is suitable in unconsolidated soils to depths of 30 meters or more. Manual percussion drilling uses a combination of a heavy chisel-like tool to break up the formation and a baler to remove the cuttings. Manual percussion is ideally suited for use in combination with other techniques to get through hard layers. It is suitable for drilling to depths of 30 meters or more, but the progress can be slow and the labor requirements are high.
I am very proud, as the mayor of Matame Rural District, to find myself today in a remote part of my district talking about low-cost technologies. I'm going to speak first, as the name indicates, about the low cost. The cost is low because everything needed in terms of spare parts can be purchased in the local market. That is to say, it can be found in the normal marketplace. This is really an advantage. Now I would like to talk about another aspect of this technology. Even the management of this modern water point has been entrusted to a group of women and men who are in the process of organizing themselves to collect, at the end of each week, the costs of maintenance. I hope that UNICEF or another program will be able to come into my district and provide more of these wells and rope pumps, because they are less expensive. And everything that is needed in terms of spare parts can be found in the local market. I insist that everything can be found locally. There are no parts that wear out that cannot be found in the local market. This is really an advantage, that we do not have to go elsewhere to order them. They are all found here.
These manual well drilling techniques are each best suited for different drilling conditions, but the end result is a well that is similar to a machine-drilled well, but at a small fraction of the cost. The design of the apron, gravel pack, sanitary seal, drainage channel, and soakaway pits are consistent with the national norms for machine-drilled wells. By creating the local capacity and reducing the costs, it will become easier for individuals and communities to invest in improving their own water supply.